For next question, it's given that an object is attached to a vertical spring and slowly lowered to its equilibrium position. And when it's slowly lowered to its equilibrium position, that is when uh, the spring is stretched and it stops. The spring stretches by a distance d. So let's say initially the spring is like this with a weight, and it's not allowed to move downwards. Now, if the object is allowed or is lowered slowly, let's say it comes and rests at this position. And now the distance by which this spring lowers is d. So the force is acting in this case is weight, which is acting vertically downwards, and in the upward force, it's the restoring force of the spring. Now the restoring force of the spring is given by F is equal to minus kx. This is the restoring force, and negative is for the opposite direction. So at equilibrium position, these two forces, when the spring stops at this position, when it's lowered slowly, it stops at this position, which is equilibrium. So that means the restoring force is equal to weight. So restoring force becomes equal to weight, and restoring force is kx. We are just taking the magnitude, and from here, sorry, it's d. It's k into d. So here the distance moved is d. So restoring force is k into d. So this is k into d. And now k is equal to mg by d. So this is the spring constant. Okay, so this is the case one. Now, if the same object is attached to the same vertical spring but permitted to fall freely, that is, it is not allowed to fall slowly, but it falls freely under the force of gravity, through what distance does it stretch the string? So in the second case, this is a vertical spring, and let's say the weight attached is initially here, and now it's allowed to fall freely, and it comes and stretches the spring, let's say by this distance x. So the spring stretches by the distance x. We have to find this x. Okay, when the string is not, or the spring is not allowed to fall freely, in this case it's the gravitational potential energy that is equal to the height above this, the ground, or this position where this stops, the block or the body stops, is the gravitational potential energy, that is mgx. Now this gravitational potential energy gets converted into here, it gets converted into elastic potential energy. So the whole of the gravitational potential energy gets converted into elastic potential energy. So that means gravitational potential energy of spring, it becomes equal to elastic potential energy of spring when it's allowed to fall freely and it stops. Now the gravitational potential energy of the spring, it's at a height x by which this spring stretches. So it is mgx, and the elastic potential energy of the spring is given by half kx squared. So this is half kx squared. Now 1x gets cancelled, and we know the value of k, which is mg by d into x. So this is the value of k, mg by d. Now mg and mg, we can strike this, and which gives us the distance by which this string stretches when the object is allowed to fall freely is 2 times the original distance when it is allowed to move slowly to a distance d. So the distance, or the distance by which the spring stretches when it's allowed to fall freely, is 2 times the original distance when the object is allowed to move slowly to its equilibrium position. Thank you for watching.